Article 695.60 of the National Electrical Code specifically addresses the tap conductor requirements for fire pumps. The statement that the tap rules of Article 240.21 do not apply to taps for fire pumps is accurate. This is a crucial exception in the code designed to ensure the reliable operation of fire pumps during emergency situations. Understanding the reasons behind this exception and the specific requirements that apply instead is essential for electrical engineers, installers, and inspectors. Article 240.21 generally governs the protection of tap conductors, which are conductors that are tapped from a feeder and supply power to a specific load. These rules are in place to prevent overcurrent situations and ensure the safety of the electrical system. However, the application of standard tap rules to fire pumps could introduce complexities and potential points of failure that could compromise the pump's ability to operate when needed most. Therefore, the NEC provides a specific exception for fire pump circuits. The exception in Article 695.60 essentially states that the tap rules in Article 240.21 are not applicable to fire pump supply conductors. Instead, fire pump tap conductors must adhere to the requirements outlined within Article 695 itself. This means that the overcurrent protection for the tap conductors is specifically addressed within the context of fire pump installations, recognizing the unique requirements for reliability and performance. The rationale for this exception stems from the critical role that fire pumps play in fire suppression systems. Fire pumps are designed to provide a reliable source of water pressure to fire sprinkler systems, standpipes, and hose connections during a fire. Any interruption in the power supply to the fire pump could have devastating consequences. Therefore, the NEC prioritizes the continuous operation of the fire pump, even under potential overload conditions, to ensure that firefighters have the water they need to combat the fire. The design and installation of fire pump electrical systems are governed by several key considerations. Firstly, the power source for the fire pump must be reliable and independent of the main electrical service to the building. This is typically achieved by providing a separate service or feeder dedicated solely to the fire pump. This ensures that a fault or failure in the building's electrical system will not affect the fire pump's ability to operate. Secondly, the overcurrent protection for the fire pump circuit must be carefully sized and coordinated to allow the pump motor to start and run under full load conditions without tripping the breaker. Fire pump motors often have high inrush currents during startup, which can briefly exceed the normal operating current. Therefore, the overcurrent protection must be sized to accommodate this inrush current while still providing adequate protection against sustained overloads or short circuits. Thirdly, the wiring and components used in the fire pump electrical system must be specifically listed and approved for fire pump service. These components are designed to withstand the harsh conditions and potential hazards associated with fire pump operation, such as high temperatures, vibration, and exposure to water. Now, let's discuss the specific requirements within Article 695 that govern the protection of fire pump tap conductors. Generally, the overcurrent protective device for the fire pump supply conductors must be located as close as practical to the point where the tap conductors originate from the feeder. The size of the tap conductors must be sufficient to carry the full load current of the fire pump motor, plus any additional loads that are supplied by the tap. Furthermore, the tap conductors must be protected from physical damage. This can be achieved by installing the conductors in rigid metal conduit, intermediate metal conduit, or other approved raceways. The raceway must be securely supported and protected from mechanical damage. It is important to note that the exception in Article 695.60 does not eliminate the need for overcurrent protection altogether. It simply means that the standard tap rules in Article 240.21 do not apply. Instead, the overcurrent protection must be sized and installed in accordance with the specific requirements outlined in Article 695. The overcurrent protection for fire pump circuits typically consists of a circuit breaker or fuses. The size of the overcurrent protective device must be carefully selected to coordinate with the characteristics of the fire pump motor and the overall electrical system. The goal is to provide adequate protection against overloads and short circuits without causing nuisance tripping during normal operation. In addition to the overcurrent protection requirements, Article 695 also addresses other important aspects of fire pump electrical installations. These include the requirements for emergency power systems, transfer switches, and supervision of the fire pump system. Emergency power systems are often required to provide a backup power source for the fire pump in case of a power outage. The emergency power system must be capable of supplying the fire pump with sufficient power to operate at its full rated capacity. Transfer switches are used to automatically switch the fire pump from the normal power source to the emergency power source in the event of a power outage. The transfer switch must be reliable and capable of transferring the load quickly and safely. Supervision of the fire pump system is also an important aspect of ensuring its reliability. The fire pump system should be monitored for various conditions such as pump running, pump failure, and low water pressure. These conditions should be alarmed at a central location to alert personnel to any potential problems. In summary, Article 695.6d provides an exception to the standard tap rules in Article 240.21 for fire pump circuits. This exception is designed to ensure the reliable operation of fire pumps during emergency situations. Fire pump tap conductors must be protected in accordance with the specific requirements outlined in Article 695, which prioritizes the continuous operation of the fire pump. The electrical engineers, installers, and inspectors must understand these requirements to ensure the safe and reliable operation of fire pump systems. The key considerations include a reliable and independent power source, carefully sized overcurrent protection, listed and approved components, and proper supervision of the system. The goal is to provide a fire pump system that will operate reliably when needed most, protecting lives and property from fire. Understanding and adhering to these requirements is crucial for ensuring the safety and effectiveness of fire protection systems. The NEC guidelines aim to balance safety and reliability, recognizing the unique demands placed on fire pump systems during emergencies. This means the fire pump can run, potentially even to the point of self-destruction, in order to save a building.